Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In the previous exercises, we have discussed different methods to evaluate integral of a function. Integration by substitution, integration of some particular types of functions, integration by partial fractions method, integration by integration by parts method. Okay, my children, we have discussed all these methods. These are only the methods to evaluate integral of a given function. Okay, my children, hereafter we use those methods only. Okay, my children, right. Now come to the exercise 7.9. Here, because of this reduced syllabus, exercise 7.8 is deleted. Okay, my children. So we are going to discuss 7.9 concepts. 7.8 exercise is deleted. For the board examination point of view, that exercise is deleted in the reduced syllabus, in the revised syllabus. Okay, my children. So we are not discussing that exercise 7.8. Right. Now come to the 7.9 exercise concepts. Okay, my children. Are you ready to listen the class? Right. See, definite integrals. Whatever the integrals we have discussed so far, they are called indefinite integrals. Okay, my children. Now we are going to define definite integrals. What is meant by definite integrals? First of all, let us discuss the notation of definite integral and what is meant by definite integral. After that, we discuss how to evaluate definite integral. Okay, my children. Right. A definite integral is denoted by integral a to b f of x dx. This notation is read as integral a to b f of x dx. Okay, my children. Please remember this notation. How to read this notation? Okay, my children. This notation denotes definite integral of the function f of x, where a is called lower limit of the integral and b is called the upper limit of the integral. Here a is called lower limit of the integral and the above number b is called upper limit of the integral. This is about a notation of definite integral of a given function. Okay, my children, understood this point? Right. Integral a to b f of x dx is the area of the region bounded by the curve y is equal to f of x. The ordinates x is equal to a and x is equal to b and the x-axis. Please observe this figure, my children. Please study this figure in this coordinate axis. First quadrant, here y is equal to f of x. We have taken this is the graph of y is equal to f of x. Here x is equal to a and x is equal to b. These are the limits, lower limit and upper limit. So this area, this shaded region denotes integral a to b f of x dx. Okay, my children, this is a numerical value. Area means in the earlier classes you have found area of a rectangle, area of a square, area of a circle, area of a parallelogram, area of a trapezium. What is meant by area of a geometrical figure? It denotes a numerical value. Isn't it or not, my children? So here integral a to b f of x dx denotes area of a shaded region bounded by y is equal to f of x is equal to a, x is equal to b and the x-axis. Okay, my children, let x be the given point in the closed interval a comma b. At any point in this closed interval a comma b, any point. Then integral a to b f of x dx represents the area of the shaded region. This shaded region denotes integral a to b f of x dx. Okay, my children. The area of the shaded region depends upon the value of x. We denote the function of x by a of x. This is called area function. Okay, my children. This is called area function. A of x is called area function. Therefore, a of x is equal to integral a to b f of x dx. Understood this point, my children? This is about notation of definite integral of a function f of x. Here, this number is said to be lower limit, and upper number, above number is said to be upper limit of the integral. And the integral a to b f of x dx denotes area of this shaded region bounded by y is equal to f of x and the lines x is equal to a, x is equal to b, and the x axis. Is this point clear, my dear children? Right. Now come to the next point. In the first point, we have discussed the notation of definite integral and what is meant by definite integral of a function. Now come to the second point. For first fundamental theorem of integral calculus. Let us discuss this point here. Let f be a continuous function on the closed interval a comma b, and let a of x be the area of the function. Previously we have discussed a of x means it denotes the area of a function, integral a to b f of x dx. Do you remember that point, my children? Right. Then a dash of x is equal to f of x for all x belongs to closed interval a comma b. This is called first fundamental theorem of integral calculus. Now come to the next point, third point. This is a very important point for this definite integral. With the help of this fundamental theorem of integral calculus, we evaluate the definite integral of a given function. Okay, my children? Right, come to this point. Let f be a continuous function defined on the closed interval a comma b, and capital letter f be antiderivative or integral. Capital F denotes integral of f of x. Okay, my children? Of f, integral of f, then integral a to b f of x dx is equal to f of x at a to b, from a to b, that is equal to f of b minus f of a. Means I will explain you how to evaluate definite integral of this function. First of all, we have to find the integral of this function by using an appropriate method. We have discussed, we have learned so many methods to evaluate integral of a given function. So by using an appropriate method, we have to find integral of this function. Let us it is f of x. This is the integral of the given function. After that, we have to write the lower limit and the upper limit here and here. Okay, my children, this is notation. After that, in this function here, we need not write plus c. Okay, my children, we should not consider plus c. We should not write a constant of integration. While you are finding definite integrals, we are not writing constant of integration. Remember this point, my children. So in this function, first we have to substitute b in the place of x. We have to substitute b. Then we get f of b. Okay, my children, understood this f of b minus. In the same function, substitute a in the place of x. Substitute a. Then we get f of a. Then we find f of b minus f of a. Then that numerical value, we get some numerical value only. That numerical value is nothing but definite integral of the given function. Okay, my children, understood this point? Right. The concepts of exercise 7.9 were completed, finished. Okay, my children. Now let us solve the problems in the exercise 7.9. Page number 338 in the textbook. Okay, my children. Right. See the question number 1. Evaluate integral minus 1 to 1 x plus 1 dx. Okay, my children, we have to find the value of integral minus 1 to 1 x plus 1 dx. Okay, my children. Here also let us assume that first I is equal to, capital letter I is equal to integral minus 1 to 1 x plus 1 dx. Okay, my children, we have to evaluate the definite integral of this function. Okay, my children. So to evaluate this function, first of all, we have to find the integral of this function. Okay, my children. So integral x dx minus 1 to 1. Okay, my children. Plus integral minus 1 to 1 dx. Here two terms are there. For each and every term, we are finding the integrals separately. You know this property. Okay, my children. Just we are writing the limits minus 1 to 1. Understood this step, my children? Right. That is equal to integral x dx. What is the value of integral x dx? It is in the form of integral x to the power of n dx. So x to x square by 2. I am writing the value of integral directly here. Integral value is minus 1 to 1 plus integral 1 dx. What is the value of integral dx? 1. Okay, my children, because integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1, and integral 1 dx is equal to x. For the first term, we used this integral formula. For the second term, we used this integral formula. Then we got this step. Understood this step, my children? Right. Now come to this first term. Here 1 by 2 is a numerical coefficient. We can write it outside. 1 by 2 into x square minus 1 to 1. We found the integral. We got the integrals. Integral part is over. Now we have to find the value. So here in this function, first we have to apply upper limit. What is upper limit? 1 minus lower limit. In this function, what I said, we have to substitute the upper limit 1 minus. In the same function, we have to substitute the lower limit minus 1. Understood this part, my children? Right. This is equal to 1 by 2 into. Here also, in this function, first we have to substitute upper limit. What we get? 1 square minus. Okay, my children? Minus 1 whole square. Okay, my children, understood this one? Right. Plus, here what we'll get? 1 plus 1. Okay, my children, understood this one? Understood this step? Right. This is equal to 1 by 2 into, what we'll get here? 1 square value is 1 minus, what is the value of minus 1 whole square? 1. Plus here what we'll get? 2. Understood this step, my children? This is equal to, here we get 0. 1 minus 1, 0. So 1 by 2 into 0, we get 0. That is why I am not writing the first term. Finally, what we get? 2. Therefore, integral minus 1 to 1 x plus 1 dx is equal to 2. This is the definite integral of the given function. Understood, my dear children? Right. Now come to the question number 2. Okay, my children. Evaluate integral 2 to 3 1 by x dx. Understood this question, my dear children? We have to find the definite integral of this function. Now come to the solution part. Let I is equal to, let us assume that capital letter I is equal to integral 2 to 3 1 by x dx. You know this step. Throughout this integral chapter, I said first step is capital letter I is equal to given question. Okay, my children? Right. Now come to the step. Integral 1 by x dx. What is the value of integral 1 by x dx? Log mod x. Okay, my children? Limits 2 to 3. 2 to 3. Because integral 1 by x dx is equal to log mod x. Okay, my children, do you remember this integral formula? So by using this integral formula, we wrote this log mod x. Understood this log mod x, my children? I wrote limits, lower limit and upper limit. So what is the next step? After finding the integral, we have to substitute upper limit first in this value. So log mod 3 minus, in the same function we have to write lower limit log mod 2. Okay, my children, understood this step? Right. This is equal to log 3 minus log 2. Mod 3 is equal to 3. Log mod 2 value is also 2. Understood this step, my children? Right. Here we have to use logarithmic properties. It is in the form of log A minus log B. What is the value of log A minus log B? Log A by B. So log 3 by 2. Because log A minus log B is equal to log A by B. By using these logarithmic properties, I wrote this step. Understood this statement is learned? Right. Now come to the next question, that is third question. Evaluate integral 1 to 2 4x cube minus 5x square plus 6x plus 9 dx. Understood this question, my children? We have to find the definite integral of this function. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 1 to 2 4x cube minus 5x square plus 6x plus 9 dx. Okay, my children? If you observe this function has different terms. First term, second term, third term, fourth term. So we use a distributive property. Means we find the integral of each and every term separately. Okay, my children. So here 4 is numerical coefficient. I have write it directly here. Integral 1 to 2 x cube dx. For this first term, I am finding integral. Here 4 is numerical coefficient. We wrote before the integral sign. Understood this property, my children? Understood this step? Right. Minus 5 into integral 1 to 2 x square dx. Understood this second term, my children? Minus 5x square is there. Here minus 5 is numerical coefficient. We wrote it outside. Integral 1 to 2, we are finding integral of the remaining part. Plus 6 into integral 1 to 2 x dx. Understood this term, my children? Right. Plus integral dx. 9 into integral dx. So for every term we are finding the integrals separately. Understood this step, my children? Limits 1 to 2. That is equal to, come to the first term. It is in the form of integral x to the power of n dx. Yes or no, my children? Yes. So what do you get? X to the power of 4 by 4. I wrote the answer directly. X to the power of n plus 1 by n plus 1. X to the power of 4 by 4. Understood this x to the power of 4 by 4, my children? Right. Limits minus 1 to 2. Sorry, 1 to 2. Not minus 1. 1 to 2. Okay, my children? Minus 5 into. This is also integral x to the power of n dx. Here also we use integral x to the power of n dx. What do you get? X cube by 3. Okay, my children? Limits 1 to 2. After finding the integral of this function, we write the limits 1 to 2. Plus 6 into, here also integral x dx, x square by 2. Here also, for the third term also, we use the integral x to the power of n dx. Okay, my children? Understood that term? Plus integral 1 dx means x, and we write limits. Understood this step, my children? For all these first 3 terms, we used the formula integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1, and for the last term, we use integral dx is equal to x. Okay, my children, by using these two integral formula, we wrote this step. Understood this step, my children? Right. So integration part is over. Now we have to substitute upper limit minus lower limit. Okay, my children? Right. 4 into, here 1 by 4. 1 by 4 is numerical coefficient. We can write it outside. Previously also I told you. X power 4, 1 to 2. For the remaining function, we write the limits. Okay, my children. Similarly here, minus 5 by 3. 1 by 3 is a numerical coefficient. We can write it outside. X cube. Okay, my children. Understood this term? Right. Plus 6 by 2. Here also 1 by 2 is a numerical coefficient. We can write it outside. For the remaining function, we write limits. Plus 9 into. In this function, lower limit, upper limit is 2 minus lower limit is 1. In this function, we are substituting upper limit minus lower limit. Okay, my children, understood this step? Right. Here 4 gets cancelled. Here in this function, first we substitute upper limit, that is 2 power 4 minus lower limit. What is lower limit? 1. So 1 power 4. Okay, my children, understood this one? 2 power 4 minus 1 power 4. Right. Minus 5 by 3. In this function, substitute first upper limit, that is 2 cube minus 1 cube. Understood this? 2 cube minus 1 cube, my children? Right. Plus, here 3, 2 ones, 2, 3 times. 3 into 2 square minus 1 square. We follow the same steps here also. Upper limit minus lower limit. In this function, we substitute upper limit, that is 2 whole square minus lower limit is 1. So 1 whole square. Okay, my children, understood this step? Right. Plus 9 into what we will get in this brackets 2 minus 1, 1. Okay, my children, understood this step? Right. Now let us simplify the terms, each and every term. Then what we get here? 2 power 4, 16 minus 1 power 4, 1 minus 5 by 3, 2 cube, 8 minus 1. Okay, my children, understood this part? Plus 3 into 2 square, 4 minus 1 plus 9. Understood this step, my children? We are simplifying the terms. Okay, my children? Right. Then what you will get here? 16 minus 1, 15. Okay, my children? Minus 5 by 3 into 7. 8 minus 1, 7. Okay, my children? Understood this is 7. Plus 3 into, what will you get? 3 minus 2 minus 4 minus 1, 3. Okay, my children? Plus 9. Understood this step, my children? Right. 15. I am directly finding the value. 15 plus 9. 3 3s are 9. 15 plus 9. What will you get? 24. 24 plus 3. 24 plus 9. 33. Okay, my children. Minus 5. 7 5s are 35 by 3. Okay, my children, understood this step? Now let us simplify these two numbers. Take LCM. Take LCM. LCM is 3. 333 is 99 minus 35. What is the value of 99 minus 35? 64. 64 by 3. Okay, my children, understood? This is the definite integral of the given function. Understood, my children? I hope you understood how to find the definite integral of a given function. First of all, we have to find the integral of the given function like this. After that, we have to apply the upper limit minus the lower limit. That is the additional step. That is only the additional step in this definite integrals. Okay, my children? Will you do the remaining sums in this exercise 7.9? Will you try the remaining questions in this exercise? Please try the remaining questions in this exercise by using an appropriate methods. We have discussed, we have learnt many methods: substitution method, integration by partial fractions method, integration of some particular types of functions method, integration by partial fractions method, integration by parts method. So by using any one of these methods, a suitable method, apply the suitable method to find the integral of the given function. After that, follow these steps, upper limit minus lower limit. That's all. Okay, my children, will you do it? Right.